In this video, we'll be finding the area of a region between two curves, only we'll be doing it in pieces. To find the area between two curves, you want to find the area under the upper curve and then subtract from that the area under the lower curve. The example that we'll be doing is determine the area of the region bounded by the graphs of y equal 2x squared plus 10, y equals 4x plus 16, x equals negative 2, and x equals 5. Our first step is to sketch the region. Our y equal 2x squared plus 10 is this parabola. The y equal 4x plus 16 is this straight line. And the x equal negative 2 and x equal 5 are the vertical lines, one at x equal negative 2 and one equal 5. So you can see why we are doing this in pieces. For this little piece right here, our parabola is the upper curve and our line is the lower curve. But then when we move to the right of this point, the line is the upper curve and the parabola is the lower curve. And then when we move past this point to the right of this point, the parabola becomes the upper curve and the line is the lower curve. So we have a piece right here that we need to find the area of. And then we have this piece right here. And then we have this piece right here. So we're going to do it in 3 pieces. So to find the 2 points where the parabola and the line intersect, we want to solve the system y equal 2x squared plus 10 and y equal 4x plus 16. Since they're both equal to y, we can set them equal to each other. And so we have this equation here. It's just a quadratic, so we'll move everything to the left side. And then to simplify, we can divide every term by 2. Get x squared minus 2x minus 3 equals 0. This trinomial is factorable, and we can factor it as x minus 3 times x plus 1. When we have 2 factors multiplied together and the product is 0, then we can set each factor equal to 0. When x minus 3 equals 0, we get x equals 3. And when x plus 1 equals 0, we get x equals negative 1. So we have not only our negative 2 and our 5 as limits of integration, but we also have x equal negative 1 and x equal 3. So then we're going to calculate this piece. We'll need the integral from negative 2 to negative 1, and then from negative 1 to 3, and then from 3 to 5. So our 3 integrals look like this. From negative 2 to negative 1, the parabola was the upper curve. So we write that function, subtract the linear function. And then from negative 1 to 3, we have the line, subtract the parabola. And then from 3 to 5, we have the parabola, subtract the line. When we combine terms inside the brackets here, we get 2x squared minus 4x minus 6. And then when we combine the terms inside the brackets here, don't forget you want to distribute the negative through the binomial here, and here, and here. But this simplifies to 4x plus 6 minus 2x squared. And then when we combine the terms here, we get 2x squared minus 6 minus 4x. And when we integrate, we're going to increase the exponent by 1 and divide by the new exponent. So we have 2x cubed divided by 3. Then we have negative 4x squared divided by 2. And then we have a negative 6x. This integral is evaluated from negative 2 to negative 1. And then the first and the last have the same integrals, so only this one is evaluated from 3 to 5. In the middle one, we increase the exponent by 1 and divide by the new exponent, so 4x squared divided by 2 plus 6x, and then minus 2x cubed divided by 3. That integral is evaluated from negative 1 to 3. Alright, so we have quite a bit of writing here. We're first going to substitute negative 1 into this expression. So we have 2/3 times negative 1 cubed minus 2. This simplifies to 2 times negative 1 squared minus 6 times negative 1. And then subtract from that the same expression, only with negative 2 substituted in. So we have 2/3 times negative 2 cubed minus 2 times negative 2 squared minus 6 times negative 2. So this first part right up to this point right here represents this first expression. And then to evaluate the second expression, we're going to sub in 3 first. So we have 2 times 3 squared plus 6 times 3 minus 2/3 times 3 cubed. Then subtract from that the same expression, only with negative 1 subbed in. So 2 times negative 1 squared plus 6 times negative 1 minus 2/3 times negative 1 cubed. Plus, and then it's a long expression, so I had to continue on the next line. This one we're going to sub in 5 first, and so 2/3 times 5 cubed minus, okay, so this is this last one, minus 2 times 5 squared, and then minus 6 times 5. I don't know why I mixed those two terms up, but addition is commutative, so it doesn't hurt anything. Then subtract from that the same expression, this expression with 3 subbed in. So 2/3 times 3 cubed. And then I interchange these, so this one is next, minus 2 times 3 squared. And then minus 6 times 3. Well, when you do all that math, you come up to be 142 over 3.